All right. All right. So again, here we have a radical expression. If there isn't a number here, that means that it's a square root, but it could be any number here. It could be a cube root, fourth root, fifth root, so on and so forth. And that number that you see there is called the index. All right, so in this case, we want to find each cube root. So that means three numbers that you can multiply times itself to get the number under the radical. And we know that 2 times 2 times 2 is 8, so the cube root of 8 is 2. All right, the cube root of negative 8. This is a real number because negative 2 times negative 2 times negative 2 is negative 8. So the cube root of negative 8 is negative 2. The cube root of 216 would be 6. 6 times 6 times 6 is 216. All right, and then if you have trouble finding a cube root, you can always just do a factor tree on those numbers until you see what the three numbers are. All right, so now let's do some roots that are higher than cube roots. This one is a fourth root. So I'll just do a factor tree on this one so you can see. 16 is 4 times 4, and then we have 2 times 2 and 2 times 2. So there are 4 2's, so the fourth root of 16 is 2. All right, if you have a negative outside of your radical symbol, you'll just carry it over into your answer. So this would be negative 2. All right, but this goes back to what I said previously. If you have an even index and a negative under the radical, this is going to be a non-real number. All right, I'm not asking you to find what that number is, but in this case, it would be 2i. But you just need to tell me that this is non-real. All right, D is the negative fifth root of 32. Again, you just carry that negative over into your answer. And 2 times itself 5 times gives you 32. So that would be negative 2. All right, the fifth root of negative 32, if your index is odd and you have a negative under the radical, that is a real number. And this would also equal negative 2, because negative 2 times itself 5 times is negative 32. So just remember that if your index is even and you have a negative under the radical, it's non-real. And if your index is odd and you have a negative under the radical, it is a real number. All right, and then part F is the negative fifth root of negative 32. So we're going to carry that negative over into the answer, and then the fifth root of negative 32 is negative 2. So a negative negative 2 is positive 2. All right, we're going to omit the graph, so I will skip example 7. All right, the meaning of the square root of a squared says for any real number a, the square root of a squared is equal to the absolute value of a. In other words, the principal square root of a squared is the absolute value of a. All right, so let's look at these examples. We want to find each square root. We have the square root of 7 squared. That's going to be the absolute value of 7, which is 7. All right, the square root of negative 7, and that quantity is squared, is still going to be the absolute value of negative 7. So it's still going to be 7. All right, so whenever you take the square root of a square, it basically just cancels itself out. But since I have this negative 7 in parentheses, I take the absolute value of negative 7, and it still comes out to be a positive 7. So the square root of k squared is equal to the absolute value of k, and I'll just leave that in the absolute value symbol since it's a number and I don't know what that number is, or it's an unknown number. The square root of negative k squared would be the absolute value of negative k, which is the absolute value of k. Whenever you take the absolute value of a negative number, you get a positive number, but because I don't know what that number is, I'll leave it in the absolute value symbol. All right, so the meaning of the nth root of a to the n power says if n is an even positive integer, then the nth root of a to the n is equal to the absolute value of a. So that's if it's even, you get the absolute value of a. If n is an odd positive integer, then the nth root of a to the n power is equal to a. So if it's even, absolute value. If it's odd, no need for the absolute value. All right, let's look at some examples. All right, so we want to simplify the 6th root of negative 3 to the 6th power. Here, our root is even. So this is equal to the absolute value of negative 3, which is 3. All right, here my root is odd. So the 5th root of negative 4 to the 5th power is just going to equal negative 4. You don't take the absolute value of it because n is odd, or the index is odd. All right, the negative 4th root of negative 9 to the 4th power, again, that index is even, so we know we're going to take the absolute value of it, but we're also going to carry that negative over into the answer. So now I have the negative absolute value of negative 9. The absolute value of negative 9 is 9, but again, we're going to carry that negative over into the answer, so it would be negative 9. All right, the negative square root of m to the 4th power is going to be the negative. We're just carrying that negative over into our answer. The negative square root, the negative absolute value of m squared. And this is going to actually be negative m squared. Okay, why did I drop the absolute value symbol on this one and not these? All right, well, there's a definition. For all m, the absolute value of m squared is equal to m squared. That is why I dropped the absolute value symbol. So there's no absolute value bars because m squared is non-negative for any real number value of m. What that means is if I take a number and I square it, it's automatically going to be positive. When you square a positive number, it's positive. When you square a negative number, it's still positive. So I dropped those absolute value symbols. I hope that makes sense. All right, the cube root of a to the 12th would be a to the 4th. And again, I don't need those absolute value symbols because if I multiply something times itself 4 times, it is automatically going to be positive. Okay, and then here, the 4th root of x to the 12th power. Well, actually, let me go back here. So here my index was odd. So that is really the reason why I don't have the absolute value symbol. But here my index is even, and what I ended up with x to the 3rd power. So since that is odd, if I take a positive times a positive times a positive, that would be a positive. But a negative times a negative times a negative would be a negative. I don't know if that's going to be positive or negative, so I leave the absolute value symbol there. So we already know if it's even, we use the absolute value symbol, but we can drop it if the exponent is even. We don't drop it if the exponent is odd. Again, I hope that that makes sense. Let's do another one. Oops. The 4th root of x to the 16th. So here my index is even, so I would put the absolute value symbol, and it would be the absolute value of x to the 4th. But because this is even, I can drop those absolute value symbol, and it would be x to the 4th. Okay, so let's look back. If the index is even and you're going to automatically keep those absolute value symbol there because the index is even, but then your result is odd, you leave the absolute value symbol. Let's look at G. Your index is even, so you automatically have your absolute value symbol, but if your exponent is even, you can then drop it. And so it would be x to the 4th. All right, example 10 says use a calculator to approximate each radical to 3 decimal places. So normally I say, we can't use a calculator, but in this case we'll need to. There is a method that we can use to estimate a square root without a calculator to around the nearest tenth with pretty close accuracy, but I'm just going to go ahead and allow you to use a calculator. So let's see if I can pull a calculator up. Let's see. Oh, wait. Let's go back. Oh, wait. There we go. Okay, so the square root of 39, if you're using the calculator on the iPad, you would punch in 39 first and then go over and tap your square root button. And so it tells me that that is 6.2449, and we want to round it to 3 decimal places. So it would be approximately 6.245. All right, let's try another one. All right, so the negative square root of 72. Of course, you would carry the negative over into your answer. And we're going to hit 72. And then we're going to hit the square root. And I get 8.485 to 3 decimal places. So negative 8.485. All right, now when you're doing something higher than a square root, there's a different button that you'll push. So first I'll type in 93, and then I'm going to go over here and tap this button that says y square root of x, or y root of x. And then I'm going to hit 3 because it's a cube root, and equals. So to 3 decimal places, that would be 4.531. And let's try one more. The fourth root of 39. So again, I'm going to type in 39 and then go over here and get the y root of x, and then hit 4 because I want to take the fourth root of it, equals. So that would approximately be 2.499. Okay. All right, we're going to skip example 11, and that is actually it.